Hello, in this chapter we are going to talk about LCD. Okay, and in LCD we have considered the alphanumerical LCD of 16 cross 2. However, we will be in the market. We can also get 20 cross 2 or 20 cross 4 LCD also. What exactly mean by 16 cross 2 is that you will get a 16 character on a one line and a 16 character on other line. So it has two lines which is of 16 character. So that's why it is called a 16 cross 2 alphanumeric LCD. And in this LCD, as we will be able to only display the alphabets and numerical value, that's why it is called alphanumeric LCD. Okay, we will also have the graphical LCD where we can print the graphics as well, but that we will not consider as a part of this chapter. So this you can see the what are the different pins you will be able to see in alphanumeric LCD is, let's say, VSS, VDD, VEE. Okay, so basically it will having the supply voltage and a ground which you need to provide for these pins, and you can have a intensity control as well. Okay, so these are the pins which will be available for that. The majorly the most important pin which we have in LCD is RS, which is yeah, we'll talk about in next, yeah, on the consecutive side. Then other one is RW, read write and enable uh, pins. Then we have a D0 to D7 data lines, and we have a LED A and LED K. Okay, so these are the pins which we will have for the alphanumeric LCD, which we need to connect to the microcontroller. So now let's talk about the more detail in alphanumeric LCD. So the alphanumeric LCD is 16 cross 2. Yeah, as it name said, I can show the, it can print up to two lines of 16 character. Each LCD character contains 5 cross 8 pixel grid. So it has a pixel grid, basically dot dots, which will construct the alphabets. The most LCD will have two registers. Okay, one will be the command register and one will be the data register. So what is the purpose of these two registers? Okay, the command register will be used if you want to send certain commands, then you need to send via this register. So required to send different commands, instruction, operation. For that purpose, this register is being used. The second one is the data register. So which the we will need to send the printed data which we want to display on the LCD. So basically that is the data part, and data, all the data content, all the that content will be handled by this register, and we need to send to this register. What is mean by command? So if you want to, there are different commands available for the LCD. Let's say I want to display the character on a first character, second character, so that is one command. If I want to I want to blink the cursor, so that is also one command. So there are different set of command which we require to send before sending the data. That's why this command register is being used. We will talk more about in this for this in next slide. The LCD have a different required commands to provide the display functionality that is being mentioned over. So for example, it is given, let's say, clear display. I want to clear the complete display, so that is one command. Shift display, the LCD itself will provide that functionality. If you want to shift the display, then there is a command for that. And for that you have a two options, shift right and shift left. Okay, then you have a force cursor position at the beginning of the line 1 or 2. So you want to put the cursor at the first line or second line. That for that also we have a command, shift the entire display right or shift the entire display left. Okay, so these are the different commands which LCD all directly provide. So now let's talk about the address, because if I want to print something, I need address to print at that line or at that a particular location, right? So what will be the address of the line 1 and line 2? As we are talking about the 16 cross 2 LCD, we have a two lines. So address of the first line is always fixed at, it is 0x80, and this is the standard um, mm, LCD, and it will always, if you are buying this LCD, any alphanumeric LCD, it will always have this 80 in hex as a line 1 and C0 as a line 2. So that's why your code will not change if you choose any or if you replace with the different LCD. Okay, So the value of the data register will be displayed on LCD. And to display the value on LCD, you need to load the ASCII value of the character in data register. So basically, we are dealing with the ASCII value whenever we are going to print. So let's see what will be the individual address of the each character on line 1 and line 2. So it will start from 80, then 81, 82, 83, 84, 85, 86, 87, as we have 8 character on the first line and 8 character on the second line. So second line will start with C0, C1, C2, C3, C4, C5, 6, 7. Okay, so these are the address for the each character on line 1 and line 2. Okay. Okay, then we will move to the next one. Okay, so now data bus. Okay, so we are now interested in the data bus content. So we have a D0 to D7. Okay, so we can interface the LCD in two mode. One is the 4-bit mode and one is the 8-bit mode. Okay, so if you are if you are configuring 8-bit mode, then we will have a direct mapping from one line, like all the 8 bits. Okay, so because D0 to D7 are the basically data lines of the LCD. Okay, which will be directly mapped to the controller. And if we are operating in a 4-line mode, then we will be having only, like, we will configure the 4 lines only, and we will again, so basically we will transport the nibble, higher nibble and lower nibble. Okay, so that's why we can interface the LCD in two mode. One is the 8-bit mode and another second one is the 4-bit mode. So let's talk about the 8-bit mode first. So now we will talk about the RS, which it is a register select. So what exactly mean by register select? As I told, we have a two register. One is the data register and one is the command register. So I need to switch between the data. I need to select the data register sometimes, and sometimes I need to select the command register. So definitely first, before sending anything, I need to send which kind of command I am sending. Okay, if I'm selecting a command first register, then I will send a command. If I'm selecting data register, then I will send the data. So that's why we need to select this data register or command register, and for that purpose we have this line. Okay, so we will select using this pin. So let's say we will just read this. So data register, to display the data on the LCD, we should write to the data register. To select between the command register and data register, the RS signal is being used to make the RS signal high and feed the input to the data D0 to D7. This will input will be interpreted as the data register. So basically, if you make the RS signal as an high, and then if you send the data or whatever the value on db0 db7, that will be treated as a data. Okay, so that is the simple things which you need to look at. And if you are selecting command register, and you need to put the RS signal or RS pin into the low, and then you need to send the like values on a db0 db7, which is the data lines, and then it will be treated as a command. So there are different commands available. As I mentioned, there is a complete list which I will show to you. So ultimately it is the same one. Let's say the second one is the read oblique write bar. Okay, so in the certain cases, let's say if you want to read, then you let's say it is, that's why it is saying read oblique write bar. Okay, so read will be yeah, so if it is read oblique write bar, it is low, indicate the write mode, and if it is high, then it will indicate the um, so I think it is reverse over here. So because it is read oblique write bar. Okay, so bar means minus. So if it is 1, then it is read. If it is 0, then it is a uh, yeah, it is same. So it is 0 means write mode. It is given correctly over here. So the next one will be so it is mentioned the signal is used to write the data uh, or command to the LCD or read the busy flag. So because we need to read the busy flag, what exactly the situation where it is busy or not. For the write operation, the RW will be low, and for the read operation it will be high. That is the same thing, enable. So now we have one more signal which is enable. So The enable signal is used to latch the data, that is to place the data onto the data bus, okay, and wait for a clock um, or a pulse to send it. And then when high to low pulse is being sent on enable line, then data will be displayed on the LCD. So basically it is high to low transition. Whenever happen on a LCD, it will latch the data. So it is mentioned the same thing. A high to low pulse is being required to send to enable the pin, which will latch the info into the LCD register, that will trigger the LCD to act accordingly. So it is very much mandatory to have a provider high to low pulse on this enable line. So yeah, I think it is the same one as we mentioned. D0 to D7 will be the data lines and which you need to connect to the controller. D7 will be alternatively act as a busy flag as well. These are the most important RS, read double write bar and enable. These are the main pins which you need to connect to your controller and program it here for a programming. And here you can see that VSS is being ground, VCC will be the plus 5 and VE will be the contrast adjustment. Now let's see what are the different commands we have. So we have a command in all the commands in hex. So one is to clear the display screen. Okay, so if you want to clear the complete screen, then you can use 01, 02 for the return to home. So basically you will come back to your home position. 4 1 will be the decrement cursor, sixth will be the increment cursor, fifth will be the shift display right, 7 will be the shift display left, 8 will be the display off, cursor off. So display is also off and cursor is also off. Sometimes you need display will be off, but you want the cursor to be on. In that case, you need to use this A. But display will be off, but cursor will be still on. On 0C will be the display will be on, but cursor will be off. So you can do that as well. You want if you want to do display on cursor blinking, that also you can do by 0E. And yeah, definitely to highlight that we will use the blinking, that's why you use 0E. If you want to display uh, on and cursor blinking, you can use 0F as well. Then you have 10, which is shift cursor position to left, 14 shift cursor position to right, 18 shift enter display to the left, and shift enter display to the right. Okay, so these are the different commands, and one more command is the force cursor to uh, at the beginning. Okay, the first line. So these are the different commands which will be available on LCD, which you can use it. Next will be how you will program it. Okay, this is the most important part where you need to how you can do that. So you need to write a simple code where let's say you if you want to send a data, then how you will send it, that you will see. So if you want to send the data, then you need to make the RS pin as in 1. Okay, so that's why it is register select and 1 is being used for the data selection. Then read oblique write bar, you will see that it is a write or it is a read operation. Okay. Mm, so basically you will send as read oblique write bar as in 0, then enable high to low transition you will set, and then you will return. So this will send the data onto the bus. Second one will be the send, yeah, second one will be the yeah command. If you want to send, then RS will be changing to 0, read oblique write bar. um yeah, I think as you want to write it, because you want to write, that's why it is 0. Okay, because we always need to send the 0 to write it. So even in the command also you need to send 0, because you want to write it from a write operation. Okay, so that's why it is 0. Then you, if you want to, yeah, you need to again send the enabler enable from high to low, then it will write it. This is the final step you need to do. So if you see over here, this is the RS signal is being low, read oblique write bar. So it is being 0. Let's just to perform the write of the operation, you need to um, select the reason 0. Then you have enable which is being 1, and then you will give some delay and make that again low, so it will treat it as a latching signal for the LCD, and which will be sent on the data line. So this is the simple function which you need to make for a write command. So let's say here you will send the command value, and whatever the command you will send, that will be sent to the LCD via latch. Okay, so send the command on a DB0 to DB7 line, select the command register this. You need to write, perform write option, that's why you will make this low and enable high to low signal with delay. Similarly, for the data write operation, the same function is being used, that way you will pass some value of a data to this function. You will get that value, you will take that value onto this data bus, this signal, and you will again set all these three register, which is RS line, then read oblique write bar to again 0, RS will be 1, which is to select the data register, then read oblique write bar to perform a write operation, and this will be high to low transition to send the data. So this way you can send the data to the LCD, which will be displayed on the LCD. Okay, so this is the simple program you need to write to interface the LCD. Yeah, and if you have doubts, you can um, yeah write or message to me. I will answer to you.